Okay, good morning, Eagles. It's a new and different time. Today's lesson, I'm going to show you how to solve a system of equations in three variables. Okay, the steps that we will be using are: number one, we're going to take this system of three equations in three unknowns, x, y, and z, and a solution. First step we're going to want to do is we're going to want to set our system up so that our x's are in the first column, y's in the second column, z's in the third column, and our solution's on the right. If there is not a variable for one of the columns, you leave it blank. Okay? And then from there, we are going to follow a certain set of rules. And those certain set of rules are going to be: number one, reduce the system to two equations and two variables. This can be accomplished by taking any two different pairs of equations and using the addition method to eliminate the same variable from both pairs. Meaning, what I'm going to do is I am going to start out by labeling my three equations as E1, E2, and E3. So I like to refer to the first equation as E1, the second equation as E2, and the third equation as E3. So I can take E1 and E2, and if I were to want to eliminate the z's, I could just add them together and these two z's would go away, and I'd have a new equation that would have 2x plus 2y equal 4, if you can see that. So I would only deal with those two equations. Now, that's our first step. So we're going to do it until we get two equations in two variables, and they have to be the same variables. Then we're going to solve that system of two equations in two variables by any method we choose. We can use substitution, we could use elimination. We're not going to use matrices here. We're going to do it by hand to show that we know the algebra, okay? Once we solve those two equations in two variables for one of those variables, then we will back substitute into one of those two equations and find the second variable. Then we will have either x and y, x and z, or y and z. Then we will back substitute into these equations, one of these equations up here, to find the third equation. And our last step will be to check our solution. So let's get started. Since the first equation has just x and z in it, I want to look at equations 2 and 3 and figure out how would I eliminate the y's to only have x's and z's, because I already have one equation right here that's already in two variables of x and y. Okay, so what we're going to do is we're going to take E2 and E3. Now, if I want to eliminate the y's, all I have to do is multiply equation 3 by 2, which will give me a negative 2y, and these two will disappear. I will eliminate them. So my way of keeping track of what I do is I will write 2E3 plus E2, okay? And my new equation will be this: x plus 2y minus z equal 1. So I'm going to take equation 2 and I'm going to write it here. Now I'm going to take 2 times E3. So 2 times 2x is 4x. And 2 times minus y is minus 2y. And 2 times z is plus 2z. Okay? Everything's getting multiplied by 2. And 2 times 3 is 6. So now, if you can see, as you can see, these are gone because 2y take away 2y goes away. So I get 5x plus z equal 7. This is my new equation, okay? And I have equation 1, which is in terms of x and z as well. So I'm going to take E1 and new, we'll call it E2. This is going to be called new E2. That's what the N stands for. I will write these out here. X plus Z equal 3 and 5X plus Z equals 7. That is not a very good bracket. I can do better than that. Okay, so now I have two equations and two unknowns. I am going to choose to get rid of the z's. I'm going to eliminate the z's, okay? How am I going to do that? Pick one. Let's multiply this by negative 1 E1. So if I do that, I get minus x minus z equals negative 3. So this got a negative 1, this got a negative 1, this got a negative 1, all of them multiplied. Then I'm just going to write my new E2 again, and I'm going to write 5x plus z equals 7. And now, using the elimination method, I can add down. 5x take away x is 4x. These go away, equals 4. So if I divide by 4 and I divide by 4, x equal 1 is my first solution. Okay? Now, we're on our way. What we have done so far is we've used two equations, equation 2 and equation 3, and we used the elimination method to eliminate the y's. And we got a new equation 2. We didn't have to do anything with equation 1 because it was already in two variables, and it drove my thinking, hey, let's use these two to get rid of y. Now, I have new equation 2, I have equation 1 right here. I chose to eliminate the z's by multiplying by negative 1. Here's my negative 1 E1. There's my new E1. Here's my new E2. I add them, I got x equal 1. Since x equal 1, I'm going to take that and I'm going to back substitute into one of these two equations. It doesn't matter. So the opposite of 1 minus z equals negative 3. So add 1 and add 1. Negative z equals negative 2. So z equals 2. Second solution. Then I am going to pick E2 or E3 and substitute. X equal 1, z equal 2, then solve to find, what am I looking for? Y. So I will solve to find y. I don't care which one. I'm going to pick E2. I just looked up there and said, okay, we'll use E2. It doesn't matter. You can take time to study them, whatever you need to do. So first things first, 1, x equal 1. So I'm going to substitute 1 plus 2y, which I don't know yet, minus z, which is 2, equals 1. So this is 1 take away 2. So it's 2y minus 1 equal 1. Add 1, add 1. 2y equal 2. Guess what y equals? 1. Excuse me. Now, I have an ordered triple. My ordered triple is x equal 1, y equal 1, z equal z equal 2. Okay, x, y, z. Okay, the only thing we have left to do is our check. All right, so if we're going to check our solution, we're just going to take our equations up top. And our first equation, E1, says x plus z equal 3. Question mark. Well, if I take 1 plus 2, it indeed equals 3. We have a go. E2. E2 says x plus 2y minus z equal 1. Well, what's our check? Our check is x equal 1 plus 2 times y, 2 times 1, plus 2 minus z minus 2 equal 1. These go away. 1 equal 1, check. Final solution. And I will not do this on the next example. I will leave it to you to check. I will show you another way to check on the next example that's even more efficient. 2x, so 2 times 1 is, well, let's write it. 2x minus y plus z equal 3. Is that true? So 2 times 1 is 2. I'm just going to do that in my head and write 2. 2 times 1 is 2. Minus y, minus 1, plus z, plus 2, equals 7. I don't know where I looked up, saw the wrong number. All right, this is harder than it looks, trying to think and talk at the same time. I miss you guys. Okay, 2 plus 2 is 4, take away 1. Oh, check. Our solution is 1, 1, 2. And that is how we solve systems of 3 in 3 unknowns. It's a bit of work. And yes, we will be required to show our work. All right. That concludes the first example. I am going to make a video for each one of these examples.